Welcome to the section 8.3 notes. This is the last video for the semester. So go ahead, pause the video, write out this complex number in trig form, and then unpause it and see how you did. So for this one, we first have to figure out what r is. So r is going to equal the square root of a squared plus b squared, right? We're just taking this thing right there. But a is equal to 1 and b is equal to negative square root of 3. Okay, a is the real part, b is the imaginary part. So r is equal to the square root of 1 squared plus negative square root of 3 squared. Well, that's just 1 plus 3 underneath that radical. So we get that r is equal to 2. Well, if r is equal to 2, that means cosine of theta has to equal that real portion, which is 1, divided by the radius, or the modulus, which is 1/2. It also means that sine of theta has to equal that complex part divided by 2. So if this is the case, theta is equal to cosine inverse of 1/2. So theta is going to either equal 60 degrees or 300 degrees. And for sine inverse of negative square root of 3 over 2 is going to tell me that theta is going to either equal, sine is going to be negative down in quadrants 3 and quadrants 4, so that's either 240 degrees or 300 degrees. All right, so since those are both 300, I get my final answer, which I'll write as z equals, it was 1 minus square root of 3 times I. This is now equal to 2 times cosine of 300 plus I sine of 300. So today we're going to talk about products and quotients in the trig form. I am going to butcher this name probably more than once. I believe it's pronounced Demoivre, but again, not positive. I feel bad because I feel like I should know that guy's name, but I'm not very good at speaking French. So maybe if you're in French, you can help me out with that one. So for this one, we have two basic formulas, I guess, if you want to call them that, for products and quotients. It looks very, very complicated. All right. What we're going to do is we're going to multiply. I'm going to say radii, but radii is technically, it's the modulus. You are multiplying the modulus of each of those. And then you are going to add the angles. So take theta 1 and theta 2, you put them together in each part. This plus sign is always going to be that plus sign. All right. With quotients, you are going to divide the radii and you are going to subtract the angles. All right. So when we jump into these, we're going to find the product first. So for these ones, when you're finding the product, that's 3 times 7. We multiply the r part, the modulus, the radii. And then inside these parentheses, I'm going to probably accidentally do this multiple times, but I'm going to try to put a big square bracket around the entire thing because these cosine terms are going to need parentheses because I'm adding those two angles together. Same with the sine. So I'll try to have that square bracket around that entire piece. So my final answer is going to be 21 times cosine of 115 plus I sine of 115. Okay, you can keep these parentheses here if you want them. If you don't want them, that's totally fine. So that is my final answer. For the next one, again, we take the r part, multiply them together, so that's the 9 times 4. Inside here, cosine of 35 plus 52. I'm getting that from just that second set, plus I times sine of 35 plus 52. So I get a final answer of 36 times cosine of 87 plus I sine of 87. It's not too bad going that way. With division, I can see where there might be a little bit more hesitation, a little more confusion, just because it's a little bit more distracting, I guess. To start, just ignore all the cosine sine business. Okay, 24 divided by 4, that's 6. So I'm just going to just put 6 right away. Now when I'm doing this, I'm going to relate it kind of to exponent rules. When you divide with the same base, you subtract the exponents. So it's kind of the basic same idea, except for they're not exponents. It's the angle measurement inside of cosine and inside of sine. So I get 6 times cosine. When I subtract 64 minus 16, hopefully I get 48. And I should have that same angle with sine. All right. So for number 4 over here, again, I'm going to start just by dividing that 36 and 12 to get 3. And I'll have cosine of 98 minus 47 plus I sine, that was a terrible n, of 98 minus 47. So I get 3 times cosine of 51 plus I sine of 51. Now, quick aside, which I breezed past a little bit. In these pieces right here where I have the parentheses, it's important that I put that because sine of 98 minus 47 is not the same thing as sine of 98 minus 47 written like this. This first one is you are going to take sine of 98 degrees and you're going to get some obnoxious decimal, which should be a positive, smaller than 1. Then you subtract 47. This says you subtract the angles. So it's important that we have parentheses in the right part. Okay, now in here, like sine of 51, that's sine of an angle. You don't need those parentheses because sine has to have an angle measurement involved. For the next one, we are going to find the product in standard form and then change these factors to trig form and find that product in trig form. So this problem is going to take up a lot of space. So don't write too big. Writing it in standard form is going to be pretty simple. We are just going to FOIL. So first times first gives me negative square root of 3. Last times last gives me an I. Inside times inside is going to give me minus 3i. And last times last is going to be plus I squared times the square root of 3. Well, that becomes negative square root of 3 minus 2i minus square root of 3. Because remember, I squared is just negative 1. So you just change the sign of whatever that coefficient was. So we end up with negative 2 square root of 3 minus 2i for our answer. All right, now, if I want to change each of these factors, I'm going to change each factor over here. So I'm going to start by figuring out what 1 plus I squared root of 3 is. All right, so my work for that's going to be below here. I'll keep it in black. You've got different colors. Using different colors is probably going to be helpful. So we know that r is equal to the square root of 1 squared plus square root of 3 squared. So that's going to be 1 plus 3. R is going to equal 2. Since r equals 2, cosine of theta is equal to the real part, 1, over the radius, or the modulus, 2. And sine of theta is equal to that square root of 3 part, the imaginary part, over the modulus, 2. I'm going to skip writing cosine inverse, but we are taking the cosine inverse to get that theta is equal to either 60 degrees or 300 degrees, because that's when cosine is positive and equal to 1/2. For the sine, again, I'm going to skip that sine inverse piece, but sine is positive in quadrants 1 and 2, so this is again at 60 degrees or 120 degrees. Since those are both 60, I'm going to get that 1 plus I squared of 3 is equal to my modulus of 2 times cosine of 60 plus I sine 60. Okay, so that's my first factor. That minus square root of 3 plus I, I'm going to do the same basic idea here. So my r is equal to the square root of negative square root of 3 squared plus 1 squared, because the coefficient of that I is just 1. So r is equal to the square root of, well, 3 plus 1. R is still going to be 2. In this case, cosine of theta is equal to the negative square root of 3 over 2. Make sure you bring that negative along from that negative square root of 3. And then sine of theta has to equal 1 over 2. So in this case, Since cosine is negative, I know that it's in either quadrant 2 or 3. So in order for it to be in quadrant 2 or 3, it's got to either be 150 degrees or 210 degrees. Okay, because this is a 30-degree reference angle. 30 degrees short of 180, 30 degrees past 180. For sine of theta to equal 1/2, theta has to equal 30 degrees or 150 degrees. 150 is the angle, so I have 2 times cosine of 150 plus I sine of 150. So that was all the work I needed in order to change them from standard form into our trig form, and now I actually have to multiply those. So I'm going to go back to that left side. I'll do this in red. Instead of that being 1 plus I squared root of 3, I'm going to have 2 times cosine 60 plus I sine 60. And then instead of it being negative square root of 3 plus I, I'm going to have 2 times cosine of 150 plus I sine of 150. To follow my rule, 2 times 2, I'm multiplying the modulus part, and then I'm going to have cosine of 60 plus 150 plus I sine of 60 plus 150. I almost stayed on the left side of that line. So I've got 4 times cosine of 210 plus I sine of 210 when I add those things together. Well, cosine of 210 I know is going to be a negative value. Okay, I know it's a 30-degree reference angle. Oh, I'm getting ahead of myself a little bit. This would be our multiplied out. That'd be our answer. But it said to check. That's kind of what I got to right away. I'll do that in green. So cosine of 210 is equal to negative cosine of 30. It's a 30-degree reference angle, but we know it's got to be negative, and that's going to be negative square root of 3 over 2. Similarly, sine of 210 is also going to be negative because it's in the quadrant 3. So that's going to be negative sine of 30, which is negative 1/2. So if I had plugged those in, I'd have 4 times negative square root of 3 over 2 minus I over 2, which would have been negative 2 square root of 3 minus 2I, which is what we got when we multiplied that out in standard form. So this was a lot of work. I'm not going to say do this type of problem very often, if at all. Basically, it was do this problem one way, do this problem a different way, just all at one time. So you can see that they are, in fact, the same thing. All right, so next we're going to talk about de Moivre's theorem. Again, I'm probably butchering that. If you're in French, maybe you can help me out and tell me exactly how to say that next time you see me in person. But this theorem, it's not complicated, but it's easy to make mistakes. Because you have 2 different pieces. So for this problem, I'll say this is equal to z. So I have z to the 5th, right? Because that's what that 5 is. When I multiply this out, I take 2 to the 5th times cosine of 5 times 30 plus I sine of 5 times 30. The mistake that I catch myself making from time to time when I think about this, and I'm not staring right at the theorem, is I remember that I'm multiplying the 5 from the exponent times the angles, but I'm still raising the modulus to the exponent. The mistake I make is I want to do 2 times 5. It is not 2 times 5, it's 2 to the 5th. All right, so 2 to the 5th is going to equal 32. Then I have cosine of 150 plus I sine of 150. Okay, now we're back to our own trig form, essentially. If I want to find this, it's written in standard form, but if I want to use de Moivre's theorem, I have to get it in trig form first. So if I think to myself, well, z is equal to 1 plus I need to get that into trig form. My r is equal to the square root of 1 plus 1, right? Technically 1 squared plus 1 squared. So I've got the radius, or the modulus, of square root of 2. Cosine of theta is 1 over square root of 2, which if I had rationalized excuse me, would be square root of 2 over 2, where that 1 comes from the real part. And similarly, from the imaginary part, I'd have sine of theta is equal to square root of 2 over 2 as well, because it would also have been 1 over square root of 2, and rationalize square root of 2 over 2. All right, so since both of these are positive, I know that it has to happen in quadrant either 1 or nowhere else. All right, that's the only place where cosine and sine are both positive. If they were both negative, then it could have been in quadrant 3, but we're in quadrant 1, so theta has to equal 45 degrees. Okay, otherwise you could have said this is 45 or 315, and this is 45 or 135. 45 is the overlapping part. So z to the 10th is equal to square root of 2 times cosine of 45 degrees plus I sine of 45 degrees, and then that is all to the 10th. De Moivre's theorem tells us that that becomes square root of 2 to the 10th times cosine of 45 times 10, or 10 times 45, again, multiplication, that order doesn't matter, times I sine of 45 times 10. I'm going to kind of break this down a little bit quicker right away, since I know square root of 2 is 2 to the half. This becomes 2 to the 5th power. Square root of 2 to the 10th becomes 2 to the 5th power. And then I have cosine of 450 degrees plus I sine of 450 degrees. Oops. So from the last problem, we know that 2 to the 5th equals 32. But cosine of 450 degrees is a full rotation plus a little bit more. So that's actually just going to be the same thing as cosine of 90, and then plus I sine of 90. So that's 90 degrees past 360 degrees. So z to the 10th is equal to 32 times, well, cosine of 90 degrees is 0, and sine of 90 degrees is 1. So I get that this entire thing, so z to the 10th, or 1 plus I to the 10th is how it was written originally, is just equal to 32I. When I distribute 32 times 0 is 0, 32 times I is 32I. All right, now for this one, same idea. We have to figure out what r is first. So r is equal to the square root of the square root of 3 squared plus 1 squared. Okay, we got that r is equal to 2 again. So cosine of theta is square root of 3 over 2, and sine of theta is 1/2. Again, these are both positive, so we know that we are in quadrant number 1. So theta had to equal 30 or 330. That's not in quadrant 1, so that's not going to work. Or same thing over here. This is 30 or 150. That's not in quadrant 1. Those are the same, okay? So you can think of it either way. Like the first ones I did were, what are all the answers? What was the duplicate? Or you can think, oh, these are both positive. What quadrant is both positive? Or if this was positive and this is negative, which quadrant has cosine positive, sine negative? You've got kind of two different ways to think about that. Either way, we now have that this can be written as 2 times cosine of 30 plus I sine 30, all raised to the 4th. So that becomes 2 to the 4th, not 2 times 4, times cosine of 4 times 30 plus I sine of 4 times 30. So again, the mistake that we're going to make is one of the two. It's either you're going to multiply instead of raise this to a power, or you're going to try to raise this to a power instead of multiply. I don't think that one's going to be as common, just because you're going to end up having like 30 to the 4th power or something like that, and that number is going to get huge really, really fast. So I'm guessing the mistake that's going to happen the most is this 2 to the 4th you're going to want to put as 2 times 4 to be 8. In this case, you'd be half as big as your final answer should actually be, because 2 to the 4th is equal to 16. 2 times 4 is equal to 8. That's just because we have a base of 2. You're not always guaranteed to have a base of 2. So when I multiply that angle, I get 120 degrees. So I know that cosine of 120 is going to be negative. All right, that's in quadrant number 2, so it's got to be negative. My reference angle, it is 60 degrees short of 180, so this is negative cosine of 60 degrees, and then plus I times sine of 120. Sine of 120 is going to be positive, still with a reference angle of 60 degrees. So I've got 16 times, well, cosine of 60 degrees is going to be 1/2, so negative of that is negative 1/2. Sine of 60 degrees is going to be square root of 3 over 2, and then times I. So when I multiply that 16 through by distributing, I get negative 8 plus 8 square root of 3i for my final answer. All right, so there below is your assignment. Make sure you're working through those problems and asking questions. We are almost ready for our test, and then we'll have our cumulative test after that, and then you're done with trig. So hopefully you've enjoyed it a little bit. You've had a little bit of a challenge, probably more so of a challenge this year than normal, but hopefully you've had a little bit of enjoyment out of it and feel a little bit more confident, especially if you are going forward and taking calculus, where you're going to be needing your trig values, your trig ratios quite a bit in calculus. But again, hope everybody has a great day, and I will talk to you guys later.